So in this tutorial, we are going to look at physical quantities and units. This is a tutorial for AS Physics, but it forms a foundation to any level of studies from here onwards till your university. So it would be interesting one if you put some focus. So what is a physical quantity? So the topic that we are discussing today is physical quantities, right? And units. Quantity, physical quantity is something that can be measured in numbers, right? For example, mass is a physical quantity because you can say something is 5 kilograms of weight, right? Similarly, temperature can be a physical quantity because you can say whether it's hotter or cooler by the number, right? How many degrees Celsius it is, like 40 degrees Celsius. So that's hotter. And then minus 10 is cooler. So there's number associated. And then there is a unit as well, like degrees Celsius. But that's not go in the units as of now. Let's keep it simple. So physical quantities can be measured quantitatively. The term quantitatively means in numbers. Basically, they have a value associated with them. So, and then these physical quantities can be divided, right? So like any other list, you have base quantities and derived quantities. Derived quantities, we will look at what derived quantities are in a bit, but let's concentrate on base quantities. So what we need to remember that there are only 7 base quantities, right? So there is only 7 base quantities. Out of those 7, we need only 5 that are highlighted here. So these 5 are the one we need for our exam, right? Length, mass, time, electric current, and temperature. So these are base quantities, right? And then there is another 2, like amount of substance and luminosity. So amount of substance and luminosity intensity is measured in mole and candela respectively. We're not going to look at them. So they are not needed for our physics exam. So these 2 don't need as of now, right? So let's focus. Length is measured in meters. Mass is measured in kilograms. Time is measured in seconds. And you've got electric current measured in amperes. And you've got temperature measured in Kelvin, right? And then, of course, already mentioned length and mass. So these are all units, right? Symbol of the unit, basically. Mass is M, kilograms is kg, seconds is S, amperes is capital A, and Kelvin is K. I'm pretty much sure you already know all this from your IGCSE examination. If you're taking this class, for sure you have passed IGCSEs, so you know all the units. I'm not going to go in detail of why we name them like the way they are. So 7 base quantities and base units. And out of those 7, we only need 5 that are highlighted here, right? So we need to memorize them completely. So we need to have them in our mind completely memorized. So you can see here, need them to be memorized, right? So just gonna get this, right? So now let's look at some derived quantities. So if these are all base quantities, what is a derived quantity? Imagine you can also measure force, 25 newtons. And then there is like, if something hits you heavier, that's like 50 newtons or 100 newtons. So there's a number. So that's again quantitative. And there is a unit, that's newtons. And there is no Newton in the list that we have memorized, right? That means Newton is a physical quantity because it can be measured quantitatively. And it is a derived quantity as well, not base quantity, right? So let's look at the first example of derived. So as we progress along the course, we will practice this more and more and you'll get used to them. So at this point, don't get like, oh, what is this? Very simple. So you got newtons, right? So Newton is, we know as a N is a unit. So we need to write anything, any units, derived unit can be tracked down to the base units, right? Any derived unit can be tracked down to these 5 quantities that we're looking at. So let's see, I'm going to use this one. So we know force is equals to M times A, right? Force equals to mass times acceleration. Force is measured in newtons, so mass is measured in kilograms. and acceleration is measured in meters per second square. So you can see Newton can be written as kg, meters per second square. Kg is the symbol of base unit, and then mass meters is also here. We have meters the length, right? And then seconds as well. They're all these three symbols are physical quantities, and they are base quantities in units, right? Basically base units here. So basically Newton is a derived unit, and kg, meters per second square, is the base equivalent of that. So that's the idea of what derived unit and derived quantities are. So force that's measured in newtons is the derived quantity. And you might be asked to convert a derived quantity to a base quantity, right? Or a unit. So that's how we do it. So let's do another example. So you can have volts, right? So let's do another example, volts. So you can see it says express potential difference volts in terms of base units. So volt is not, we cannot see volt here in this list, right? That means volt is a derived unit. Volt is basically work done per unit charge. That's volts. Work done per unit charge is volt, right? The unit of volt is V, and work done is force times distance, and charge is current times seconds, right? So we already know F is equals to ma, and distance is s, and I is amperes, and s is seconds. As you can already see that a and s are already in base units. So this is done. We need to convert ma to their base equivalents, right? So let's keep it. So V is equals to, we know ma is kg, a is meters per second square, and then that's multiplied with distance, which is another m, and then divided by as. Now it's getting a little bit messy here, so I'm going to show you the same thing, same calculations here, just a little bit simpler. So here you can have volts is work done per unit charge, work done is force times distance, charge is IT, you know this from your O levels, F equals to MA and S, and then IT, we convert MA as kg meters per second squares time S. So the S here will convert to meters, right? The unit of distance is meters. And so you have 1 meter, 2 meter, that makes kg meters squared, right? You can see here meter squared. And then second to the power minus 2, there's one in the at the bottom. So if we pull it up, that's going to be minus 3, and ampere is also at the denominator. If we pull it up, it's going to be e to the power minus 1. So you can see kg, meters, seconds, and amperes are all base units. So volt, this is what? This is a derived unit, right? So we essentially converted a derived unit to base unit. So as we progress in the course, if we continue on, we will learn more of this. So this is just an example, 2 examples, and maybe there are like 5, 7 other examples, and they all are similar. And we need more practice to this. Anyways, so the last thing that I'm going to touch is in O levels, A levels, IGCSEs, IL, you'll find N, mu, M, K, small k, M, and G oftentimes written. You need to know whenever there's G written, it's 10 to the power minus 10. Whenever there's M written, 10 to the power minus 10 to the power, sorry, whenever G written, 10 to the power 9. Whenever M written, 10 to the power 6. Whenever there's K written, 10 to the power 3. Milli 10 to the power minus 3, mu 10 to the power minus 6, nano 10 to the power minus 9. So this is something that you should remember, although with practice, it kind of gets like pretty normal. But yeah, as of now. Anyways, that's the end of the lesson. We'll see if we get to talk in the next lesson or not. Thank you.